Hey y'all, it's James. Wanted to do a short video on heat units for you. So I'm going to talk about the heat unit formulas. There's a couple of different ones just to tell how many heat units you're acquiring with each exposure or a number of exposures altogether. There are two rating charts that I'll show you, and then anode cooling charts, which are not the same thing. And I've also seen these called anode cooling curves in certain books. So to start off with, we got the heat units, which is just how we measure thermal energy in the anode. And we call them heat units, or we can also measure them in joules. And it depends on what kind of generator you're going to use. So for a single phase unit, your heat units are your kVp times your mass, and that's going to be equaled. So if you had one heat unit for 1 kVp and 1 mass, that would be equal to 0.7 joules. Now, if you had a three-phase or high-frequency generator, your heat units, it's still kVp times mass, but now we're throwing in 1.4 as an extra multiplier. And so one heat unit would equal to your kVp times your mass times 1.4, and that would give you 1 joule for every 1 heat unit. And that's just because the three-phase or high frequency, don't have that huge voltage ripple that the single-phase units do. So then, if you did multiple exposures, you would just add or multiply however many exposures you had, to the end of this formula. So if you did, 3 exposures with the same kVp and the same mass, you would just say, your kVp times your mass times 3 equaled, however many heat units you had. Okay, here's a tube rating chart. So these are just telling you what techniques are safe to use. So if we look at the one up in the top left corner over here, we can see that at 75 kVp, is around there. If we were using 200 MA station, we could go up to 0.1 on our time, because that's where that crosses. Or we could go to 1 second if we were using the 150 MA station, because we would be safe there. And if we went all the way to 10 seconds, we would have to be using the 100 MA station, because, the line's up there. These seem pretty straightforward to me, and so I wasn't having a lot of trouble with the tube rating chart. Sometimes they're called radiographic rating charts. But what was confusing me was the anode cooling chart. So this is telling you how long you have to wait for your anode to cool back down. And this wasn't making sense to me, because I was thinking, wait a minute, this looks like it's saying if we're at 350 heat units, that I wouldn't have to wait at all. It'd be, immediately back down to 0. Or if we were at 50, I'm going to have to wait longer? This doesn't make sense. So, but what it actually is if we are at, say, 350, and we want to get, down to we'll say 50, then how long am I going to have to wait? So if we follow the line down from here, it is at 350, and it goes down to right around there, so it's just over 5 minutes you got to wait for it to cool down from 350 to 50. Let me try another example here. If we were going to wait for the tube to cool down from, let's say, 250 here, right? So it crosses the line there-ish. I'm having trouble drawing. So that's, around that level. And now we wanted it to wait until we got to 50 again. And so, there's the line. So that's more about 5 minutes, right? Because we're starting at around 2 and going to 7. So it would take about 5 minutes for it to cool down from 250 to 50, whereas 350 to 50 took more like 7 minutes. So that's the idea with using these charts. Anyway, hopefully that helps clear some stuff up. If you have any more questions, just let me know.